In this video, I want to take a look at a couple of theorems that we almost would take for granted. In fact, the first one I think we have in the past, but we need to actually prove that it's true. So here we go. Let A be an n by n matrix. If B is a square matrix such that BA equals I, then B is A inverse, and likewise on the other side. In the definition of A being invertible, we said there exists a B that when you multiply it on either side, you get the identity. This theorem is saying that if you have something that acts like the inverse on one side, then it actually is the inverse, and it will work on both sides. So it doesn't matter if you start with it on the left, it's the inverse, or if you start with B on the right, it's the inverse of A. So to prove that, we're going to use the theorem that we had. In fact, I'm going to go back here and just remind you of it, the equivalent statements, right? Why is this down here? That theorem that we had was for an n by n matrix A, the following are equivalent. In particular, A is invertible and AX equals 0 has only the trivial solution. So if the homogeneous system, with the matrix A being the coefficient matrix, if that has only the trivial solution, then A is invertible, and vice versa. Okay? So we're going to use that to do this. Here we go. Here's the proof. So let's assume that we have BA equals I. Why is that moving like that? Suppose BA equals I. There we go. Now look at the homogeneous system AX equals 0. We know that it's got at least one solution because it always has the trivial solution. So let x0 be any solution, be an solution. How about any solution of AX equals 0? Okay. So because it's a solution, we know that if you plug it in, that's a true statement. Now multiply both sides by B, and we get B A x0 equals B times 0. The B times A here, well, that's I. That's what we assume that we had. And B times 0 is 0. I times x0 is just x0. And so what we end up with here is that x0 equals 0. I let x0 be any solution, and I showed that any solution had to be just the trivial solution. Hence, the homogeneous system AX equals 0 has only the trivial solution. By the equivalent statements theorem, then this tells me that A is invertible. So now we have the following. If A is invertible, then A inverse exists, and I can talk about A inverse. And we started with this, that B times A equals I. We'll multiply both sides on the right by A inverse. The A times A inverse is definitely I. The I times A inverse is A inverse. B times I is B, and so you end up here with B is A inverse. So if it looks like the inverse on the left-hand side, it is the inverse. Likewise, and I'll leave this for you to do, you can make a similar argument on the right. So we proved if you have a left-hand inverse, then it is an inverse. You can do a similar thing on the right, but I'll leave that for you to do. Now, what do I want to do? I want to look at the next theorem here. Okay. Let A and B be n by n matrices. If AB is invertible, then A and B must also be invertible. We had a theorem a couple of days ago that says if A and B are invertible, then the product is. This is going backwards. This is saying if the product is invertible, then so must each of these be invertible. So what we're going to do is we'll again use that equivalent statements theorem to get the results we want. So I'm going to look at the homogeneous system Bx equals 0. Right? I'm essentially trying to prove that B is invertible by finding that this has only the trivial solution. So let x0 be any solution to this system. because it's a solution, I know that when I plug it in, that bx0 equals 0. Right? Multiply both sides by a, so a b x0 equals a0, so a times 0 is 0. ab, oh, I just did that. Right, so there's that. Now I'm going to multiply both sides by AB inverse. The thing is, I know AB is invertible. That's given in this problem. So if AB is invertible, it has an inverse. I'm going to multiply both sides of that equation by AB inverse on the right. And I notice that I don't have this in parentheses. So there we go. Now, AB inverse times AB is just I. AB inverse times 0 is 0, and then I times x0 is 0. Sorry, is x0, and so I end up with x0 equals 0. I let x0 be any solution to this system, and it turns out that it had to be the trivial solution. So this has only the trivial solution, which means that B is invertible. So if B is invertible, then what I do is I say, notice that I can write the matrix A as AB times B inverse. This is given as invertible. B inverse is invertible because its inverse is B, and we just proved that B was invertible. So now I have A written as a product of invertible matrices, and we proved earlier that a product of two invertible matrices is invertible. So A must be invertible as well. Okay? So if the product AB is invertible, then so are both A and B.